Now let's talk about sampling and inference to start our discussion on polling. So we've talked a lot about random variables in this series, and we know about the different distributions of random variables, how to find the expected value and standard error. And we started with these games of chance because it's very easy with games of chance to think about all the possible outcomes and then their probabilities that are associated with them. However, now we're going to kind of switch gears. We're going to start talking about how random variables relate to gathering information about large populations from small samples. And this idea is known as inference. So inferential thinking and statistics often go together because many times in statistics, we don't know something about a population and we want to use statistics to help figure that out. So we take a sample to find out about a larger population, and we usually don't have the resources to ask every single person in the population our question. So instead we can select a small sample and use it to make inferences about our larger population. So that's kind of the main idea. And before we go more into sampling, I want to just go through a few quick definitions. So we've mentioned a lot of these throughout this series, but I'm going to formally give a definition to a lot of them. So the first one is population. And when we say population, we're referring to the whole class of individuals about whom the investigator wants to generalize. So Wade, what are some common populations you see in polls?
So here at the University of Illinois, we often will talk about all of the U of I students or all US adults.
Those are both two great ones. And remember that our population, if we're sampling out of that population, our sample is only representative of that population. The next definition is sample, and the sample is just the part of the population that the researcher actually looks at, the people that they actually collect data on. And then inferences are basically putting samples and populations together. It's generalizations about the population that come from the sample. And then parameters and statistics are two terms that come up as well. Parameters are facts about the population. You can remember it, parameters, population, they both start with P. And then statistics are estimates of those parameters, and those are computed from the sample. And again, statistics start with S, so sample and statistics, easy to remember. So the main idea in sampling is that we want our sample to be as close to the population as possible. And the closer our sample is to the population, the more accurate our inferences are going to be. So let's think about which methods of sample selection are best. So I have three here. And as we're talking about these, I want you to keep in mind the goal is to make the sample and the population as alike as possible. So the first option is that the researcher handpicks the sample to resemble the population on all relevant characteristics. So if the researcher wants to take a sample and ask that sample a certain question, like let's give a context. What question? Say we wanted to do a survey. What do we want to ask?
So one survey I loved looking at recently was a survey that surveyed all, I think it was US active voters.
Yes.
And one question they asked was about their education.
Yeah, so say our population is all US active voters and we want to know what percent of that population has gone to college. So the researcher would pick a sample, and we're saying this option says they hand pick the sample. The second option says the researcher publicly posts the survey, nowadays usually online, and allows anyone to respond. And then the last option says the researcher uses something called simple random sampling, meaning that the sample is randomly selected and every single person in the population has an equal chance of being chosen. So thinking about these three, which one is best is the question. And just like experimental design, I'm going to go ahead and say that the random sampling is always best. And the reason it's best is because it eliminates any selection bias. And we don't want bias in our polls. So I'm going to say this eliminates selection bias, and also it's the most likely to make the sample as close to the population as possible.
And I feel like I see that second option where an online poll a lot. Like every news site will always have a poll, and it seems like the answers are always so skewed.
Yes, exactly. So the second site is actually might even be the worst one.
Interesting.
And you see this a lot with political websites. A lot of times they'll post a poll and the poll will skew one way, because if you're going to a website that is more Republican, then you're probably a Republican. If you're going to a website that's more Democrat, you're probably more Democrat. So these types of polls that are publicly posted online and allow anyone to respond are never really random samples. And usually the population of people that respond to those polls are a specific population different than the population you want to generalize about. So for this one, I would say this one is not good. Usually, these are incredibly biased, and the results are meant to influence the public opinion in a certain way. So a lot of times people will try and use these polls to prove a point or to say, the way I think about this issue is right, look at this poll. But they're incredibly biased, so avoid them if you can. The first one is interesting because it actually says the researcher handpicks the sample to resemble the population on all relevant characteristics. So basically the researcher would say, hey, I know all of this information about the population, let me make sure the sample kind of matches that. And this is a good idea to get to know your population, but anytime a researcher is handpicking a sample, they could potentially have biases that they aren't even aware of. So this, I would say, is good as a first step, but final selection should be random.
So a researcher may look at a survey they want to do and see that the age may be a big factor in the results. So they may choose to seek out different age groups. But then once they have a lot of people from those age groups, you want the final selection to be random?
Exactly. So this is, again, a lot related to experimental design. It's good to think about possible confounders or things that could affect your results on your survey.
So you said the last option's the best.
Yes.
How would you use, if you had a bunch of people that you were potentially going to survey, could you use Python to select some of those people?
Actually, that is such a good point. So back in the day, when people were choosing who should be surveyed, they would do things like flip a coin. And a lot of surveys have like 1,000 people, which is very tedious. Now we can use Python to do this very easily. So Wade, I think you know a command that can help us randomly sample people in Python.
So df.sample is my go-to row selection that lets me select just a random selection of rows. And I can either use frac is equal to some percentage. So if I want to select 10% of people, I can say df.sample of fraction frac is equal to 0.1, or I can say in equals 10 if I want to just select 10 people for my entire sample. So there's two different ways to look at it, and I can get it either by a percentage of people or by a fixed number of people.
That is great. And this does random sampling, so it really helps people doing polls because you can easily get a random sample. So the very last thing I want to say about sampling is that you can trust polls that do random sampling because we know there's no selection bias. Sure, there are other types of bias that we want to try and minimize, but these are, out of these three options, the random sample is definitely the best. And that's going to make our inferences the most accurate if we do random sampling.